Now that we've learned how to create a code that can listen for key events, we're actually going to have a project that uses KeyListener in it. So our next project is going to be a very simple game that allows our user to move a block around the screen with keystrokes until they can make their block collide with a green circle. The user's block will always start in the same place, but the location of the green circle will be determined by using random numbers. So the first thing that I want to do is I want to show you how to create a random number in Java. The first thing you have to do is import java.ling.math. This is the same package that we imported that had square roots in it and powers. This also has the ability to create a random number. So it has a random number generator in it. And the way that you do that, once you've imported this above your class, is you make the method call math.random. And what this does is it creates a double type value, so that's something with a decimal on it, that's going to be in between 0, including 0, and 1, not including 1. So it's going to be some kind of a decimal in between 0 and 1. Now for our project, what we're going to want to do is create a number between 1 and 500. So you want to do math.random and then multiply it by 500. This would create a random number between 0 and 500, including 0, but not including 500. The trouble is, to be a location on our screen, we cannot have decimals on the end of it. So the last thing that we have to do here is to typecast our math.random times 500 to be of integer type. So putting the phrase int inside of parentheses in front of this math.random times 500 inside of parentheses creates an integer random number that's going to be between 0 and 500. So now only integers will be options for this because you've typecasted it as an integer. So you will be using this command right here to generate both an X and a Y location for your green circle. Next, and probably one of the most challenging parts to this code, is to be able to detect collisions between your user's block and the green circle. So we have to be able to do the logic that would figure out when these two things are interacting with each other and figure out if there's been a collision. So let's say that this is your user's block, which has an X coordinate of X1 and a Y coordinate of Y1, a width of W1, and a height of H1. One of the first things you want to do is understand where the four corners of this block would be at. And by the way, when you want to paint this on your screen, that would be a g.fill rect. And you would use the two coordinates, X1 and Y1, with commas in between them, and then give me the width and the height of how big to paint the block. Well, anyways, this corner would be at X1, Y1. This corner would be at X1 plus W1, comma Y1. This corner would be at X1, comma Y1 plus H1. And this corner would be at X1 plus W1, comma Y1 plus H1. Then we have the coordinates for our green circle. The top left corner for the green circle is going to be X2, Y2. And again, there's going to be a width and a height that you could add on to this. So this one would be painted with a g.fill oval because it's a circle. So the right corner would be X2 plus W2, comma Y2. The bottom left corner would be X2, comma Y2 plus H2. And the bottom right corner would be X2 plus W2, comma Y2 plus H2. You have to make sure that you understand where all the four corners are for both the user's block and the green circle in order to figure out if there's been a collision. I'm going to help you take a look at the logic of figuring out exactly when a collision will be happening. Now there's four different sides to our user block, and I'm going to help you come up with the logic for the right side and the top side, and you're going to have to figure out the logic for the left and the bottom. So one of the things you have to understand is there would be a collision on the right-hand side if the block and the green circle were overlapping anywhere from here all the way down to here. So it's not just one spot along this side, it's anywhere from here all the way down to here. So let me slide this all the way up. And at the very top position where you just barely have a collision, these four conditions have to be true. If your x2, that's the lower left corner, that's the x coordinate for the lower left corner of the green circle, is bigger than x1 and smaller than x1 plus w1. So if it's in between here and here on the blue block, and, so we've got two ands for that. And now let's take a look at the y coordinates. y2 plus h2 is the y coordinate for the lower left-hand corner of the green circle. That would have to be bigger than y1, which is the y coordinate at the top right of the blue block. And it would still be colliding as long as, and all the way down to this position, where y2, which is the top left corner of the green circle, is smaller than or equal to y1 plus h1, which is the bottom right corner of the blue block. So these four logic commands with the ands in between there would represent a collision happening somewhere along the right-hand side. Now let's take a look at what the code would look like for a collision along the top. So again, you have to consider sliding it from the very furthest left all the way to the very furthest right where there would still be a collision. So the four logical commands that you see down here connected with the AND connectors would be if, let me slide it all the way over, if x2 plus w2, which is the x coordinate of the right-hand side of the green circle, is bigger than or equal to x1, which is the x coordinate of the left side of the block, all the way out to x2, which is the left side of the green circle, being smaller than or equal to x1 plus w1, which is the right side of the blue block. And at the same time, y2 plus h2 would have to be bigger than y1 and smaller than y1 plus h1 at the same time. So all four of these logic commands would have to happen, and that would represent a collision somewhere along the top side of this block. Now, I am going to show you the pictures for the left side and the bottom, but you will have to figure out the logical commands like I did right here. So this is what it would look like for the left side. A collision anywhere from here all the way down to here. So think about when this dot would be inside of these two dots, all the way up to when this dot would be inside of these two dots. So you come up with an if statement that has the four logical commands to figure out a collision along the left-hand side, here to here. And last but not least, you'll have to figure out what it would look like for a collision along the bottom. So again, that would be anywhere, anytime the green circle is from here, with that dot just barely inside of the left side of the blue block, all the way over to here, where the left side of the green circle is just barely inside of the right side of the blue block. You figure out the logical command that would figure out a collision anywhere along this bottom, here, all the way over to here. Now, once you've figured all that logic out, you should be able to create your game. Remember, you're going to be using the up, down, left, right arrows to represent movement of the player's block. So you got to remember what the key codes were for that. And just to show you an example of what this code is going to look like when you run it, remember when you have an applet, there's no main program, so you're just running the applet. And the blue block is always going to start off at 100 pixels to the right and 100 pixels down. That's the top left corner of the block. I can move the block up, down, left, and right by using my arrow keys. So you can see I'm moving the block with my keys right now. The green circle, its coordinates were generated randomly using the random number generator as I described in the notes. So I never know where this circle is going to pop up. Every time I run this game, it's going to end up in a different spot. Now watch what happens. I should be able to run my square all the way around the circle, not touching it, and no collision happens. However, if I actually run my block into the circle, it should tell me that I've won. And that's when the game ends. Now, I put an extra part into my program where if the user types R, they can play again. So if I hit the R button, it recreates a new random number for the green block, for the green circle, and I can now move my block around and try to collide with that. You do not have to put the restart feature in there. That's just something that I did for fun. Anyways, if anybody is interested in extra credit, it would be very interesting, and you could start thinking about something you might want to do for a final project if you turn this into a two-player game. So the other version that I have for this, and this would only be for extra credit for anybody who wants it, in my second version of this game, I've made 3 dots. So instead of just painting 1 dot with random X and Y coordinates, I'm actually doing that for 3 different dots. I'm also going to have 2 players in this game, a blue player and a red player. My blue player is controlled by the up, down, left, right arrow keys. So up, left, down, and right. And my red block is controlled by the AWSD buttons. So again, you'd have to go and use that keylogger to figure out what the numbers are that correspond to AWS and D. Now watch what happens when I move my blue block into a position for colliding with the first green circle. You can see along the bottom, I have a g.drawString command that's showing me the scores for the blue and the red player. When the blue player collides with the first green circle, it adds one to the blue player score. And then when I move off of that circle, the circle's no longer there. I can do the same thing with the red block. When the red block runs into one of these green circles, it adds 1 to the red player score. Down here, you can see that. Now, when I eventually collide with all of the green circles, all 3 of them, it's going to tell me an overall winner for the game. So watch this. The red player won because the red player collected 2 of the dots and the blue player only got 1 of them. So I can make either one of the players win. So in this one, I'm actually going to collect all 3 dots with the blue block, leaving the red one just stay still. And there you go, blue player won because they collected all 3 of the dots. So have fun with this. Remember that 2-player game is only for extra credit if you want it, but you do have to do the 1-player game for credit for Project 8.